All right, so we're gonna look at some applications of logarithms. First example, we're gonna talk about sound. So sound is measured in decibels, and we use the formula D equals 10 times the log of S, where D is decibels and S is the magnitude higher than the lowest sound that can be heard. Okay, so how much higher is it than the lowest sound that we can actually hear? Okay, so our first example we're gonna say is if a baby crying is normally around 72 decibels, how much louder is that than your lowest hearing range? Okay, so what we're gonna do is we're gonna plug in the 72 decibels into our formula and we're gonna solve. So 72 decibels, well, D is our decibels, so we're gonna put 72 in for D right here. So we're gonna have 72 equals 10 times log of S. Okay, so we're really trying to figure out S here. Okay, how much higher it is than the lowest sound that can be heard. So when I'm solving this, I first want to simplify it as much as I can. So on the right side I have 10 times log of S. We're trying to find this, so I want to get this by itself. So what I'm going to do is I'm going to divide both sides by 10. Okay, so 72 divided by 10 would be 7.2 equals log of S. Okay, so log of S is going to be 7.2. I need to know what S is. So what I can do is I'm going to flip this to what we're used to. We're used to seeing log of S equals 7.2. And I'm going to change this to an exponential function so that I can actually solve for S. So this is a common log. I don't see a base written, which means I know it's base 10. So I'm going to say 10 to the 7.2 power is going to equal S. Okay, so then I'm going to go into my calculator and I'm going to type in 10.72. Okay, you can see this. So I'm going to type 10 and I'm going to raise it to 7.2 power. And it gives me this big number. All right, so it gave me 15,848,931.9. Okay, so this is how much louder it is than the smallest sound you can actually hear. Okay, so once again, all we did was to isolate our logarithm, get log by itself, and then I just switched it so we could see it like we normally used to seeing it, and then we did our spiral method, and then we just had to plug that in the calculator to get S. Okay, so now we're going to say if laughing is 1,200,000 times louder than the lowest sound that you can hear, then how many decibels is laughing? Round to the tenths. These scenarios aren't accurate, by the way. I'm just making up numbers to go with examples. All right, so it's telling me how much louder it is than the lowest sound you can hear. So this number is my S. So our S is 1,200,000. Okay, we want to know how many decibels is laughing. So we're trying to figure out our D here. Okay, so that formula we were given up above was that D equals 10 times log of S, right? So in this case, we're given our S. So D equals 10 times the log of 1,200,000, okay? I want to know what D equals. Well, D equals is already by itself, right? So all I need to do now is just type in 10 times the log of, we're going to go 10 times the log, where's log? Log of 1,200,000. And we get 60.8. decibels. And that's it. So if you go to desmos.com/scientific, okay, you will have a scientific calculator that looks like this. If you go over to functions, it'll give you your log. Okay, so if we were to type in that example, we would have 10 log 1,200,000. And it gives us that 60.8, okay? It's automatically gonna do log your common log, so log base 10, which is what our examples are. All right, our last example for applications of logarithms. It says the Richter scale measures earthquakes, and it's given by the formula R equals log of A, okay? R is your Richter number, and A is the scale of vibrations above normal, okay? If the vibrations are 7 million times worse than normal, what is the Richter to the nearest tenth, okay? So let's plug in what we have. Vibrations are 7 million times worse than normal, okay? A is the scale of vibrations above normal, so our A is going to be 7 million. Okay, and then it's asking us to find out what is the Richter. Okay, we're going to round to the nearest tenth. So we're trying to find R. So we have R equals log of 7 million. Okay, well, my R is by itself. So all I need to do is plug this into my calculator. So we have log of 7 million. And it gives me 6.8. So our R is 6.8. If the number after the 8, remember, was 5 or greater, then this would round to 6.9. Since the number after the 8 is 4, or if it was less than 4, then we would leave it as 6.8, okay? So this earthquake would be a 6.8 on the Richter scale.